In this video, we will continue to practice evaluating inverse trig functions such as these. Throughout this video, I will expect that you have memorized the restrictions on inverse trig functions. And if this is your first video, then you'll see how I use these, but this has to be memorized. And you also need to memorize your basic trig facts. All right? You need to memorize these 5 values. Okay, when you have an inverse trig function, what you do is you ask yourself the secant of what angle is equal to 2 radical 3 over 3. Now I am more familiar with the reciprocal trig function. Secant is the reciprocal of cosine. So if I take the reciprocal of both sides, this becomes the cosine of what angle is equal to 3 over 2 radical 3. Now, this is not one of the things that I have memorized, except for, actually it is. It's just in a weird form. So if we were to rationalize the denominator real quick, all right, where you would just do radical 3 and radical 3. Radical 3 times radical 3 is 3. So that would give us, hold on, that would give us 3 radical 3 over 6, okay, because this is 2 times 3. And then 3 goes into 6 twice, so this is radical 3 over 2. So this is really just radical 3 over 2. So really the question is the cosine of what angle is equal to radical 3 over 2. And that should just be popping into your head right now as pi over 6. Okay, because we memorized that the cosine of pi over 6 is radical 3 over 2. All right, it's in the first quadrant, so I don't have to think hard about it. I don't have to worry about the restrictions because look at all of these. All of these, the blue zone is the zone where the function is defined. All of these are defined in the first quadrant. So if I get a first quadrant answer, I know it's good. Okay, problem number 27 is a little bit different. Okay, because I'm taking the tangent of another inverse trig function. All right, which is fine because an inverse trig function is an angle. This is the angle whose sine is 3/5. Now, I am not going to figure out what that angle is because 3/5 is not one of the values that I have memorized. Okay, so, but the good news is I don't need to find out what this angle is to find the tangent of it. What I need to do is draw a diagram. Okay, so here's what's happening. If the tangent is 3/5, okay, that means, remember how, no, I'm sorry, the sine is 3/5. Okay, this is the angle whose sine is 3/5. So, sine is y over r. So that means this is y and this is r. So that's what I'm going to draw. I'm going to draw, okay, so I'm going to have this. So the r, the radius is 5, and the y value is 3. Okay, so, and you know what, I could have drawn this in the other quadrant, all right, that would have been possible, okay, I could have put a 5 here and a 3 here, except for one thing. Inverse sine is only defined on the right-hand side of the unit circle, okay, so that's how I knew not to draw it over here on the left. Okay, so it definitely had to be on the right, so here it is. Now, in order to find the tangent of this angle, I'm going to need to know what the other side is. Now, this is a common Pythagorean triple, all right? I'm thinking about the 3, 4, 5 triangle. So I know that this side is going to end up being 4. If you did not know this, the triple, this Pythagorean triple, 3, 4, 5, then you would have to do the Pythagorean theorem and find this side. Anyway, if I know that this is 4, and now I want to know the tangent of this angle. So the tangent is simply y over x. Okay, so that's going to be 3 over 4. So that's why the answer is going to be 3 over 4. All right, so I never did find the angle. I never did find the angle whose sine is 3/5. But I drew the angle whose sine is 3/5. And then I was able to take the tangent of that without ever knowing what the angle was. Look at number 28. Please remember that an inverse trig function is an angle. So we are just taking the cosecant of an angle. What angle is this? This is the angle whose sine is 6 over 7. Now, I am not going to find out what that angle is. Instead, I'm just going to draw this angle. So I'm going to draw the angle whose sine is 6 over 7. And here's how I draw it. I know that sine is y over r. So that tells me that 6 is y and 7 is r. Okay, so I'm going to draw that. So here's a radius of 7. The y value needs to be 6. Okay, by the way, I knew to draw it in this quadrant instead of the second quadrant because inverse sine is only defined on the right-hand side of the circle. Okay, so I couldn't draw it over here. And down here would be negative. So now in order to find the cosecant, all right, so here's a picture of the angle. All right, I don't know what the angle is, but this is a picture of an angle whose sine is 6 over 7. Now, I'm going to try to find the cosecant of this angle. So remember, the cosecant is the reciprocal of cosine. So remember that cosine of an angle is adjacent, this is the reciprocal of sine. Okay, this is the reciprocal of sine. So, since the sine of this angle is 6 over 7, okay, cosecant is the reciprocal of sine. So, since the sine of this angle is 6 over 7, then the cosecant of the angle should be 7 over 6. Okay, so even though I don't know what the angle is, I know the cosecant is going to be the reciprocal. So that's why the answer is going to be 7 over 6. So here I've got the inverse cotangent of the cosine of 0. Okay, so the inverse cotangent of cosine of 0. So what is the cosine of 0? So here is angle 0 right here. What is the cosine of this angle? Well, remember the cosine is the x value. This is the point 1 comma 0. So there's my cosine right there. Okay, so the cosine of 0 is 1. So that means I have the inverse cotangent of 1. So when I'm doing an inverse trig function, I'm asking myself, okay, the cotangent of what angle is equal to 1? I'm more comfortable with tangents, so I'm going to do the reciprocal of both sides. And I will ask myself, the tangent of what angle is equal to 1? Because the reciprocal of 1 is still 1. So hopefully you've memorized that the angle that comes to mind right now is pi over 4. Okay, that's definitely the reference angle because the tangent of pi over 4 is 1. Okay, now since that happens to be in the first quadrant, I know this is actually going to be my final answer. All right, so this is going to, the final answer will be pi over 4. Okay, because everything is defined in the first quadrant. All right, let's take a look at number 30. The tangent of the inverse secant of this. Now, this is not one of my special angle answers. This is not on the chart that I've memorized. So that means I can't find the inverse secant of this number. Instead, I'm going to have to draw a picture of it. Okay, so here I go. First of all, secant is the reciprocal of cosine. So I know that cosine is x over r. That means that secant is r over x. So that tells me that the radical 26, that's r, and the 5, that's x. So even though I can't find the angle, I can draw it. So I'm going to draw a picture of this angle. Okay, so the radius is going to be radical 26. Okay. The x value is going to be 5. And so the angle that I have drawn is right here. So this is the angle whose secant is radical 26 over 5. All right, r over x. So I don't need to know what this angle is. I need to find the tangent of this angle. Now, the tangent is y over x. So I'm going to need the y value. So in order to find the y value, I'm going to have to do the Pythagorean theorem. So that's why I'm going to do, so this is y that I'm looking for. So 5 squared plus y squared is equal to radical 26 squared. So that's 25 plus y squared is equal to 26 because the radical goes away. Subtract 25 from both sides and I've got y squared is equal to 1. Take the square root of both sides and I've got y is equal to 1. Okay, so y is equal to 1. So I'm going to go ahead and put a 1 right here. So now I can go ahead and find the tangent of this angle, even though I don't know what it is. All right, I know that the tangent of the angle is going to be y over x. So that's going to be 1 over 5. All right, so that's it. That's going to be the answer. Okay, because all of this is simply an angle. All right, I drew the angle, and then I found the tangent of that angle, and it's 1/5. Okay, pi over 2 is a special angle, so I should be able to evaluate this. So I'm going to start by finding what the cosecant of negative pi over 2 is. So cosecant is the reciprocal of the sine function. So I will start by asking myself, what is the sine of negative pi over 2? Okay, well, this is a quadrantal angle. All right, so the sine of negative pi over 2, okay, negative pi over 2 means we're going clockwise. So this is negative pi over 2 right here. The coordinates of this point are 0, comma, negative 1. Sine is the y value. Okay, so the sine of negative pi over 2 is negative 1. So then what is the cosecant of negative pi over 2? That should be the reciprocal of this. Well, the reciprocal of negative 1 is still negative 1. Right? If I take a negative 1 and I put a 1 on top of it, I still get negative 1. Okay, so fine, the cosecant of negative pi over 2 is negative 1. That means I have the cotangent, well, the inverse cotangent of negative 1. So now I can just ask myself, the cotangent of what angle is equal to negative 1? Because that's what an inverse trig function means. All right, what angle will give you this answer? I'm more comfortable with tangent, though. So I'm going to take the reciprocal of both sides. So I will say the tangent of what angle is, and the reciprocal of negative 1 is still negative 1. All right, so the tangent of what angle is negative 1? Well, ignore the negative sign for a minute, and you will be able to find the reference angle. So the tangent of what angle is positive 1? That would be pi over 4. So that tells us that the reference angle is pi over 4. Okay, so look, you should not have to draw this. You should be picturing this in your mind. But here's a diagram of pi over 4s. All right, all 4 of these angles have a reference angle of pi over 4. The tangent of any of them will be some kind of a 1. It's just that I will have a positive 1 in the first and third quadrant, and I will get negative 1 in the second and fourth quadrant. So in this case, I want negative 1 for an answer. So that means I'm going to be dealing with either this angle or this angle. All right, but I can only have one of them. I can't have two answers or it wouldn't be a function. So it's going to come down to the restrictions. And be careful, because remember, even though the last thing that we did was tangent, remember that this is actually an inverse cotangent problem that we're doing. So we need to use the restrictions for inverse cotangent. So inverse cotangent is only defined between 0 and pi, the top half of the unit circle. So with that in mind, we're sticking to the top half of the unit circle. We're going to choose this value. So that's going to be 3 pi over 4. Okay, for this one, the sine of pi over 3 is something that we actually know the answer to. So we can just go ahead and do that. So I'm going to have the inverse cosine of, but the sine of pi over 3 is radical 3 over 2. Okay, that's just something that we memorized. So now we can go ahead and deal with this. When you look at an inverse trig function, this is an angle. It's the angle whose cosine is radical 3 over 2. In other words, the cosine of what angle is radical 3 over 2. And again, this is something that you should have memorized. Jumping into your head right now should be pi over 6. And that's in the first quadrant, so that's just going to be the final answer. Okay, we memorized that the cosine of pi over 6 is radical 3 over 2. Radical 165 over 15. This is not one of the answers among the 9 values that I have memorized. That means I'm not going to be able to evaluate the inverse cosine of this number. I'm not going to be able to find that angle. It's not one of the ones I know. So even though I can't find the value of the angle, I can draw it. So that's what I'm going to do. Remember that cosine is x over r. So that's what I'm going to draw. Okay, so r is 15. And x is radical 165. Okay, so my triangle is like this. So this is radical 165. Okay, so this is the angle. So the inverse cosine of this number is an angle. I don't know what that angle is, but here's a picture of it. So now I need to find the secant of this angle. All right, all of this mess is really just an angle. So I'm finding a secant of the angle. And this angle is the angle that I just drew. So I need to find the secant of this angle right here. So what is secant? Well, secant is the reciprocal of the cosine. So if I know what the cosine of the angle is, then secant will just be the reciprocal of that. So cosine, of course, is x over r. So the cosine is radical 165 over 15. So the reciprocal of that is going to be 15 over radical 165. So that's going to be the answer. And of course, this just makes sense, and we really didn't need to draw a picture of it if you really understand it, since secant and cosines are reciprocals of each other. Okay, this is the angle, right? This is the angle whose cosine is radical 165 over 15. So the cosine of some angle is this. So the secant of that angle, of course, will be the reciprocal. Okay, last one. Now, radical 13 over 2, that is not one of the values that I have memorized. So again, I cannot evaluate this, so I have to settle for drawing a picture. Secant is the reciprocal of cosine. So I know that cosine of an angle is x over r. That means that secant of an angle is r over x. Okay, so that means that this is r and this is x. So when I draw my picture, I'm going to keep that in mind. Okay, so here's my point, and so my radius is going to be, I forgot to say x. So my radius is radical 13. And so for my x, I need to drop this down. And so my x is going to be 2. And this would be the angle right here. So this is the angle whose secant is radical 13 over 2, r over x. So I don't need to know what that angle is, I just need to find the cosecant of this angle. Okay, because this whole expression really represents an angle. This whole thing is theta, which I just drew. So I just need to find the cosecant of theta. I need to find the cosecant of the angle I just drew. Okay, now what is cosecant? Well, cosecant is the reciprocal of the sine function. And I know that sine is y over r. That means cosecant should be r over y. I have r, I don't have y. So I need to find y. So I will need to do the Pythagorean theorem. So if this is y, then I've got y squared plus 2 squared is equal to radical 13 squared. So that's y squared plus 4 is equal to 13. If I subtract 4 from both sides, that gives me y squared is equal to 9. If I take the square root of both sides, I get y is equal to 3. Okay, so the y value is going to be 3. Now I can do the cosecant of this angle, which is r over y. So that's why the cosecant should equal radical 13 over 3. All right, cosecant is r over y. So I just did r over y. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.